Okay, today we're going to be talking about this device which was seen on Star Trek The Next Generation. It's a portable biomedical device. When you see it in the videos, it was laying on the chest of the person and had this pattern going on and everything. Anyway, this was a requested project by a fellow YouTuber, and when they post their videos on it, I'll include links to what they do in the description down below. Now this may end up being a multi-part video because I want to show how to build this. I'm going to put the files up on Thingiverse if you want to make your own. I don't know how much of the build I can do since I don't edit videos. As soon as it gets to a point where like glue has to dry, or if the phone rings or the dog's one in or out, I'll stop the video and then we'll do a part 2. But for now we're going to start with a part 1. And you see I have a back which is going to be held on with 2 screws. In this case I have the screws already out, so we wouldn't have to deal with me taking the time to unscrew it all. I've got a slide switch over on the side here. I decided to make mine operate off of 2 AAA batteries. You could just use a single 9-volt battery, but in order to make it fit in there, you would have to, when you 3D print this part, change the scale in your slicer on the Z, add another 5 millimeters, let's say, so you can get enough depth to put the 9-volt in there and still get the back cover on. Okay, so on the inside, this is what we're looking at here. We've got a slide switch, and the person I was making this for decided they'd rather have me glue the switch in instead of having visible screw heads coming through on the cosmetic side. Something I wouldn't normally do, but that's what we're going to do here. I'm going to glue the switch in. Underneath this battery pack are these 4 red LEDs with their connections, and I'm running those directly off of the 3 volts through a current limiting resistor. In this case it's like a 39 ohm resistor because all 4 of those LEDs are wired in parallel. But I'm also taking that 3 volts and taking it over to this boost voltage converter. This little device here will take anything from 1 volt or even just a little bit low. I think it was 0.9 volts, and it'll boost it up to a solid 5 volts out, which I wanted to use to run this circuit. This is an inexpensive circuit that you can buy just about anywhere. AliExpress, eBay. These came off Amazon. When you get them, they're going to look like this. They're already going to have LEDs mounted on them and the whole thing. The pot is a speed control pot, so if you want it to go faster or slower, you can adjust it at that point. For our application, we're going to have to remove these LEDs, and we're going to need to set the reset to reset on count 8. This is a 10-stage sequencer, which if we were to put power on there, it would go, from here and then start over and then start over. Well, we only have 7 LEDs in the body figure on the front of this, so on the 8th count I want it to start over. So what we're going to have to do is we're going to have to take pin 15 of this little teeny surface mount device, pin 15 being right there, and we're going to need to lift that up off the board because right now they've got it grounded so that it won't reset, so it'll do the full 10 count. Well, we need to take that pin 15, and if you're really good at soldering to little itty bitty places, you can just take pin 15 and wire it right over to pin 3 and you're done. But for me, since it's very hard dealing with these very small things and trying not to make solder bridges and stuff, I'm just going to go ahead and take a wire from pin 15 and bring it down to the 8th LED hole once we've removed all these LEDs, which will then reset the counter automatically. So, let's see here. How do we want to do this? I think I'll just leave this guy sitting here. That way you can pull back reference to it. So here's the body part. This prints as one part on your printer. It'll print this way. You enable the supports like so. Then do your full paint job on the whole thing. And I think the first thing I would do would be to glue the slide switch in, because if you screw that up, if the switch no longer works or the super glue goes where you didn't want it to go, you may end up you know, damaging the case to get the switch out and start again. So do that first, because you wouldn't want to go through all the work of doing the circuits and the LEDs and everything else, and then find that you screwed it up and have to print a new part and start over. So I'm going to be using the same little slide switch that I like to use in a lot of my products or devices that I design. And it's basically 19 millimeters from screw hole to screw hole. And it just happens to be a double pole, double throw switch, but I just bend those over, and we're only going to be using, you know, 2 of the contacts, just an on-off type thing. The important thing is, when they sell these switches, they sell them with different lengths on this handle right here. This particular handle is 5 millimeters from here to the top of the switch. And this would be considered one of the short ones. They come longer. 6 millimeters, I've seen them all the way up to 10 millimeters long. And they're handy to have for some projects. For example, on my crawling eye one, I wish I'd had the longer one instead of this 5 millimeter one, because of where I mounted the switch, the longer one would have protruded out and been easier to turn on and off. But if you buy the longer ones, this is just plastic. So all you'd have to do is, you know, take your favorite little hobby saw or Dremel tool or whatever and cut the thing down to where it's about 5 millimeters. In the end, there's a little cap piece which we 3D print. As you can see, it's got an inset there, and that's going to get glued onto the end of that. So you just kind of need to make sure that they fit in together. So we're going to start at that point. And the way I'm going to do it is I have this super glue that I found. And if this end piece here doesn't open up, I'll snip it off. Oh, it opened up. Usually does seem to. The thing I liked about this particular one is it not only came with screw caps that you could screw on here to seal it up, but it came with a whole bag full of these little end pieces. This is just pushed on there. And when you get it, those end pieces are long. And basically as they clog, I just snip them off and snip them off. I'm just about to the last snip that I can get by on that. But what that allows me to do is to get this glue into tight places. And in this case, when I put the glue in, I'm going to try to get it like into the screw hole area, and I'm going to want to hold it so there's no way the super glue can flow back up into the switch. I want it to just kind of stay there, and then I'm going to hit it with some of the old instant set, the quick set. There's all kinds of stuff you can buy here. I've just had that for years and years, and it's what I'm going to use. So let's see how this goes. Trying to stay in camera and do this gluing at the same time will pose to be basically impossible. So just give me a moment here. Okay, I've got it just on the end tabs of that switch. Let's get some of the quick set in there. It's things like this where I would normally just go ahead and, you know, stop the video, and then we'll move on to part 2 later. Okay, I can still move it, so I didn't super glue the trigger part. Now hopefully that glue is set up enough so when I turn it this way it doesn't run any of it down into the switch. If it weren't on camera I would wait longer and just be sure. Okay, now I'm trying to get the other side. Like so. Okay. Now I can just take a clothespin and I just put it across the end of the glue like that, and usually I can open it back up without too much trouble. So I hate to rush this because I don't want the glue to end up running back into that switch and plugging anything up. I want to make sure that it really has set up in there. So you can see I just kind of got near the screw holes into the plastic and built it up so it's in there. Then the knob part, you can screw it up here too, of course. If you get too crazy with the glue, you end up gluing things solid. I'm going to put just a little bit right down on the center in there, and maybe just a little bit on the sides. Like I say, these little tips make it a lot easier to get it right where you want it, and not where you don't want it. Okay, let's see how this goes. I'm going to keep my thumb on the back side of the switch so when I'm pushing this on, I don't accidentally push the switch loose and screw everything up. I can't really get in there to spray anything on that, so this one I really wish I could just let sit like this for a while till I knew all that liquid had solidified in there, to make sure it isn't going to accidentally ooze back and maybe glue my switch. I think we're going to be okay though. We're gonna hope that we're going to be okay. All right, so now the next thing that I think I would do is I would take the 5 red LEDs that stay on steady. They're just standard red LEDs. That's your 5mm diameter, of which I'm digging out of this bag right here. And basically they're all going to get wired in parallel. Now if you haven't worked with LEDs before, almost all of them will have a long lead and a short lead. Your short lead is going to be the negative, the long lead is going to be the positive. So this is your cathode, short lead, negative, and your anode is the positive long lead. So when I put these in, I'm going to put them in such a way that it's going to be easy to solder all the negatives together. So I'm going to put them towards the center. Now I'm going to show you a close-up of what I'm doing here. I'm pushing them into place with my fingers right now, so there's a whole lot there that you need to see. Okay, so hopefully you can kind of see that I've got all the negatives in the center. That way, well, the next thing I'm going to do is put some super glue around those and glue them in so I know they're not going to move. But then I could start bending all the negatives together so they all touch in one place, and then try to bring all the positives on one side together so that they're all together in parallel. So let's do the gluing. Doesn't going to take much. I just want to make sure that they don't move later and screw everything up. I want to hold them in place. Fortunately on this part, you can't really put the glue in a place where it's going to be a problem, unless you've made your holes too big for them, and then it would come oozing out the front and look crappy. But they fit very snug when I put them in. As long as we're gluing LEDs, we might as well do the ones for the body. Now, the guy that I'm making this for had a DVD, I believe, and went frame by frame to figure out the sequence order that the LEDs flash in on the green ones. So on these green ones, you're going to want what they call a 2mm LED. What you can see basically is the back side of the LED is much larger, but the very tip, the visible part, is just 2mm. And again, the same thing holds true with these. You've got a long lead and a short lead. Your short lead is your cathode, your negative. The long lead is the positive or anode. And again, in these, I'm going to need to tie all of the negatives together. There's a common negative. The positives, in this case, we're going to keep separate because they're going to be driven by a circuit. And the order that I was talking about that the LEDs are going to flash in, I want to be able to visualize that. So I've taken the order from the person that I'm doing this project for, inverted it to look at from a back view, and then numbered them. The top of the head is number 1, and number 2 is down here, and number 3 is up here, number 4 is like the belly button. There's your 5 on the other leg, then 6 and 7. So I'm going to take these, and again, the only thing I'm really going to be thinking about at this point is what's the easiest way to connect all of the negative leads together. And we've got room to play with here, so it isn't really like it's critical. In other words, I don't think there's really any way you're going to do it wrong. So I'm just kind of setting them in there. And these, I wonder if it would be easier, since they stick up so tall and there's so many of them so close together, whether I should be trying to glue them in place one by one or all together. We're going to find out. We're going to find out what would have been the right way to do it and what would have been the wrong way to do it here in a second. Again, I'm not too worried about it. It's just negative leads. We can surely bend them around and make things work no matter what. Okay. Get back in there. Now these ones don't fit as snugly for me. I must have cleaned those holes out already with a drill bit. Kind of wish I hadn't. I liked it when they fit very snug, because then I don't have to worry about the glue migrating past them into the front. But I'm just going to try and put a little drop of glue next to each one, because I don't want them moving as we're trying to solder to them. All right, we'll give that a second to sit. I'll cap off my super glue while we're doing that. And let's hope that the front still looks good. Good. The front still looks good. We didn't screw anything up. Does our switch still work? Ah, good. Switch still works. So far, so good, everybody. So, to make these LEDs flash in sequence, what we're going to do is we're going to start with this sequencer board, which we've already kind of talked about. And in order to prep the board, which I've already touched on lightly, we need to remove these LEDs. Now there's two ways that you can really do it. You can use your regular soldering pencil and go on there first with the soldering pencil and fresh solder, because the solder that they use in the factory doesn't melt as nice. Go in there and hit them with some fresh solder gloves. We don't really care how much. We're going to shake the excess off. And try to hit 2 pins at a time so that you can pull the LEDs off one at a time. You want to be careful doing that so you don't interrupt the traces on the top side. Now the very first one of these that I attempted to do, I said, well, let's see if there's an easier way. What if I just go in here with my snips and just kind of pinch and snip and remove the LEDs? And when I did that, it actually ended up breaking the traces on the board, because I want to be able to solder to the positive ones up here to make counting easier. You would think that if this LED is here and that resistor is there, that must go to pin 1. No, none of that's true. Count number 1 is not pin 1 on the chip, and that resistor and this resistor do not correlate to the LEDs that are right next to them. These things are stacked up and the traces go all over the place. So you got to try not to screw that up so that you can just solder to the bottom and keep everything straight. Now, the easiest way to remove those, if you happen to have the tool, and I happen to have the tool because, starting way back in 2015, 10 years ago, and then for about a 5-year period, I was in a group called Robot Raven, and we used a 24-track digital recorder. And everything inside that 24-track digital recorder was surface mount, of course, and all the connectors and everything else. And it had some very intermittent problems. And I ended up having to work with a magnifier, electronics sometimes, and sometimes just a magnifier glass. But I had to do a lot of resoldering and reflowing. So I ended up getting a reflow solder station. Basically, just think of this as a heat gun, and you can set the temperature that you want here. When you lift it out of the cradle, it starts up, and you can see the temperature is going up right now. It goes up really quick. You can set the temperature you want there, and you can put different nozzle tips on there. This has got a little teeny itty bitty one, which is kind of cool. But I haven't got enough hands to hold everything, so I'm going to attempt to do this with this, which I have never tried it this way before. I'm trying to think of the best way to hold things so that I can do it and you can see something. I think I need some needle nose. Let's keep that in the picture. What I'm going to do is try to hold the LEDs one at a time. So let's see what ends up showing up on camera. And this cord is not long enough. I have to put this thing in my lap. Alright. I think I got enough things in my lap and everywhere. Let's see if we can do some damage here. It should be able to melt the solder. There we go. There's one. There's two. So much easier than a soldering pencil. But only if you happen to have the tool. Almost got that one out. 3. There's 4. I don't know if any of this is showing up on camera or not, because I'm having a hard enough time seeing what I'm doing without trying to look at what the viewfinder sees. Kind of give you a close-up there so you can see how they're coming off. See, when you see, the nice thing on this side of the board is you can actually see the LED placement, so we know which is the, the cathode and the anode and where we're going to end up soldering. So let us continue. Which side would you like to see? The side I'm heating, maybe? Try not to blow in hot air on this 3D printed parts, because this is extremely hot, as you can imagine. It's melting solder. I don't want to warp anything. Like I say, there's absolutely no reason you can't do it with a normal soldering pencil. It simply takes longer. It'll go quicker if you refresh the solder, like I said, with some fresh 60-40 tin lead. Okay, I think we're done. Yes. Alright. But since I had already owned the tool, I figured why not use it. Now these little red LEDs, you can certainly save them and use them in other projects. These are 3mm red, and they could come in handy for all kinds of things. In fact, I'm almost always looking for some of those. Just try to bunch them up over there. Okay. So when you look at this, you can see there's the flat side, the delta. That's the diagram from an LED. So we know that pin 1 is going to be the drive that we want, and pin 2 is a ground. We don't need the ground. And you go to your next LED, that pin is going to be the positive. So when we solder our wires on, it's always going to be on this flat side of that little triangle and not the straight line side where we're going to make our connections. So the next tricky part, and I have my regular soldering gun set up here, so I don't know how much of this will end up showing. And this wasn't tricky. It just takes time if you're using a soldering pencil, and it goes rather quick if you're not. So we have to get to pin 15, the reset. See, this is pin 1, they count down this way, and they go back up that way, and that's pin 16. We've got to get to pin 15, and we basically want to peel that leg up off the board so that we can solder to it. Now this end of this is already broken off. I might have to get a fresh blade, because I need something pointy. Yeah, I'm going to have to get a fresh blade. So let's get a non-damaged blade, and I can't turn that by hand. There we go. that out of there. It's always cheapest just to buy a big bag of these things. Because if you're doing projects, you're going to dull them or you're going to break them. It's guaranteed. So, when the time comes, just buy yourself a quantity of them so you've already got them sitting around someplace. Okay. Can I do this while on camera? Let me turn off the soldering blower down here so we can make it a little quieter. I don't know if I can stay in camera and do this or not. We're going to find out. Getting the pointy end. I'm trying to get underneath that leg of number 15 and I'm going to try and pry it up. Yeah, sure. You could use your soldering gun and try to melt that without making a solder bridge to all the other pins next to it. And I could have used my surface mount soldering iron there to basically melt the solder on all these and then bend this leg up a lot easier. But I'm not. I'm going to be doing it the same way that you'll probably have to do it if you have these kinds of tools laying around. Now, of course, you don't have to work surface mount. You can get these same kits in the normal dip package, which is much larger, and it makes it much easier. In fact, you don't even have to buy this. You can buy the components separately. This is just a 4017 decade counter. This is just a 5.5 timer. And these are just current limiting resistors. There's no reason you can buy all this, but the reason that I buy this is to buy the chip, buy the pot, buy the timing resistor and timing capacitors. It's going to cost you 5 to 6 times more than just buying this thing for a couple of dollars. In fact, they normally sell these in 2-packs. So if you get the 2-pack and you happen to screw one up, you got another one to fall back on. I think this might have been surface coated with something. I think I'm having trouble getting underneath it. I also can't see well enough to know when I'm underneath it. I'm going to have to eventually get a magnifier or something out here to look at it to see if I've gotten it up or not. Sometimes they coat the tops of these boards with a lacquer to kind of waterproof them, moisture-proof them. Okay, I can see that I'm doing some sort of damage, so that's good. There we go. See, you got that little leg up in the air. So if I haven't damaged the whole thing, and we don't know that yet, I'm going to take a wire and I'm going to solder onto that leg that I have up in the air. Then I'm going to count down to the 8th place. 1, 2, 3, 4, 5, 6, 7, 8. And this one, first dot right here on the 8th one. So it's right near that last resistor. So I'm just going to take a wire and go from there to pin 15. But like I say, if you've got really good eyes and you've got a really pointy soldering gun, you could go 1, 2, 3, go to pin 3, and just solder from pin 3 right over to 15, and that'll give you your reset also on the 8th count. And I think that's about as far as we'll take this video. The next video will start with the common grounds on all the LEDs, showing this reset, and we'll just take it from there.